So, hi everyone. So we'll start now how to score sleep stages, and Dr. has explained the basics of the polysomnography and how we measure the brain activities and how we measure airflow, how we measure EEG activity. Those things has been explained. I will, in some parts, I will explain some part of how to measure it, but Dr. Arun has explained it very well. And now we will start with the scoring of sleep stages. Okay. So this is like digital specification, or you can say technical specifications for the measurement of the EEG activity. Dr. has what routinely we use according to American Academy of Sleep Medicine, that EEG, when you are going to use it, keep it like in the range of 0.3 hertz to 3.5 hertz, and EOG also same, EMG like 10 hertz to 100 hertz, and notch filter on the place like the frequency, like if you are in India, you have to use like if data is required wherever it is, like if India 50, it's European country, US like 60 hertz. Okay, so sampling rate, Dr. has already explained. So what minimal sampling rate we have used for EEG 200 hertz, EOG same, EMG same, ECG snoring 200. Since abdominal movements are slower, so their sampling rate we also consider low, and body position is even slower. So 1 hertz sampling rate is sufficient to record body position. Okay. For the sleep stage scoring, how to score that stage is the Epoch you see is N1 or N2, N3. REM sleep, for that we need at least EEG, EOG, and EMG. Okay. And, okay. So we need at least these three. Okay. So EEG is very important, and in EEG we must have 3 electrodes at least: frontal, central, and occipital. So 3 electrodes should be EOG, 2 electrodes must be there, and in EMG at least 2 electrodes should be there for scoring. Other parameters for diagnostic purpose are scoring your airway flow, like okay, so or some REM behavior disorders, muscle disorder, movement disorders like PLMS. You need all these things, apnea. Okay, but for sleep stage scoring, these 3 are enough. And for other purpose, we can use also these things. As Arun said already, that there are different sleep cycles throughout, and there is like 4 to 6 sleep cycles per night usually. And the first half of it is dominant with slow wave sleep, and second half REM sleep, and your first sleep cycle start from here and ends here. This is one cycle. Then second cycle start from here, ends here. This is called second sleep cycle. Okay. So this is first, second, like this is third, fourth. So you see the REM sleep is increasing. Okay, and deep sleep decreasing. Okay. So this early sleep is dominant with slow wave sleep. Late sleep is dominant by REM sleep. Okay. So general scoring of sleep stages, the terminology we are going to use is stage wakefulness is known as stage W, and stage N1, that is also called non-REM 1, stage N2 also called non-REM 2, stage N3 non-REM 3, and stage REM 3. So in some textbook it also given stage non-REM 3 and non-REM 4. Actually those has been put together now. They are both are called N3 and non-REM 3 and non-REM 4 is known as now this is N3. Okay. This is non-REM 3 plus 4, both are same now. So in that is Ricketts-Kaffen scale. According to AASM, this non-REM 3 and non-REM 4 is same now. They are together now, and both are called now one stage, that is N3. Okay. REM stage is called stage R. So this slow wave activity, what is slow wave activity? The activity between the frequency of 0.5 to 2 hertz and the amplitude. Suppose this is slow wave and the peak to peak amplitude, like how much it is there. It should be more than or equal to 75. Okay, this one. So, and it should be measured from the frontal region. So that is called slow wave activity. So it has a definition according to AASM. So 0.5 to 2 hertz, and that is the amplitude of that. Okay. So these already Arun has described. Okay. So when we are going to score a file, what first we have to do? We have to mark a epoch. Epoch is your screen is there. Suppose this is your whole screen. Okay. And from here to here, suppose this is it, and your this timing is 1 epoch. So how much time you have to take? So initially R and K scales they were using like 20 seconds, some were using 30 seconds, but according to AASM it is like 30 seconds. So first epoch means the data you are seeing, it is of 30 seconds, next 30 seconds, next 30 seconds, like that. 1 hour goes, 2 hours, 7 hours goes, 7, 8 hours goes, like that. So 30 seconds, 30 seconds, 30 seconds, how we take the data. So first 30 seconds, it's wake, all right, next, and 1 hour and 2 are wake, whatever. So according to that, we have to assign that epoch, that 30 seconds, whether it is wake or sleep, REM sleep, what are the stages. Okay, so that is called epoch. Okay, so 30-second epoch commencing at start of study assigned to a stage, and each 30 seconds of the data, we have to assign a stage like that. So what if we have like if 2 or more stages coexist during a single epoch, assign the state comprising. So this is a general rule. There are specific rule later on we will discuss about that. This is general rule. If like single epoch is there and there are 2 or more stages, like wake is also there, N1 is also there, N2 is also there. So in that case, we have to mark that the comprising the greatest portion of the epoch, that will be called as then we have to assign that stage according to the stage which cover most of the part. Okay, like here. So we'll discuss about this alpha and R. So here this is 12 seconds, this is 11 seconds, this is 7 seconds. So this is alpha is the, if your EMG increase, alpha is also there, then it's wake stage actually. So it is comprising 12 seconds, 11 seconds, and then we have to mark this stage as wake. Okay. Okay, next. Okay. Okay. So this is wake stage, how to mark a wake stage. So for wake stage, we can do one thing, that we have to see first, as I told, EEG is there, EOG there, EMG there. On the basis of these 3 parameters, we have to mark it as wake stage. So when so this is stage, wake stage. Okay, so EEG pattern with eyes open. So when person is not sleeping and eyes open are there, so how the EEG look like? Okay, so EEG pattern with eyes open consists of low amplitude activity. Okay, so that consists of low amplitude activity. The activities like alpha may be there, beta may be there, theta may be there. So there is no rhythm in between. So that is called desynchronized activity. Okay. So if that is there, that is means eyes open. If you put the electrodes, you see the screen, then it is, you will notice that this is a like desynchronized activity, and high EMG is there also. So this, you know, that eye blinks are there, vertical eye movements. Dr. Arun has explained how what is the mechanism behind the vertical eye movements, eye blinks, and the frequency is like 0.5 to 2 hertz, and rapid eye movement associated with normal or high chin muscle tone Okay, so rapid eye movement may be present during the wake stage as well as in the REM stage, not N1, not N2, not N3. Okay, so rapid eye movement are present only either wake stage or REM stage. And in wake stage, reading eye movement are also there, like you are reading something slowly, suddenly you look again, start from the left of the line, so it will come like this. Okay. So this is called reading eye movements, like slowly you are reading a line, suddenly you are, so those kind of movements, eye movement, okay, you can see like, okay. So reading eye movement looks like this kind of. So rapid eye movements, we'll discuss about rapid eye movement because I will show you in the diagram, this figure. Okay. So what if patient is disconnected from the machine? You have put the electrode, but machine is not connected. Person wants to go washroom, and if that is there, you have to mark that stage. Although data is not there, but you know this is person is was connected and now went to washroom. That stage should be. Even the patient is sleeping in the washroom. Even then, you have to mark it. Okay, because you cannot know, you don't know that person is sleeping there or not. But as per the rules, when person is disconnected from the machine, it is, you know, stage wake. So this is what wake stage, eyes open. So just like if somebody puts EEG electrode, EOG electrode, and EMG, so this is how this is EOG, okay. Okay, and this is EEG. Quite noise is there because muscle activities and that can also happen. Okay, and this is EMG. Okay, so you can see here, this is rapid eye movement is happening here. Okay, so what is rapid eye movement actually? Rapid eye movement when initial deflection is less than 500 milliseconds or 0.5 seconds. If any deflection of the eye, initial deflection, if it moves suddenly, then like first deflection is less than the 500 milliseconds, equal to 500 milliseconds, okay, or 0.5 seconds. So that movement is called rapid eye movement. If it is more than 0.5 seconds for like this, so it is more than 500 milliseconds, and it's called slow eye movement. Okay. So this is desynchronized EEG and EOG is like blinks are there. You can see this one. These are the blinks. Okay. Okay. So why blink is happening only not this EOG electrode, and why? Because you place the electrodes here up and down like that. Okay. According to AASM, you have to place the electrodes like this. So if this one is upward, okay. As Arun said, that our eyes carries positive and negative charge, cornea carries positive and retina carries negative charge. So when you close your eyes like this, this charge from the cornea goes up, and the electrodes near to that will get deflection. Similarly, happening here, this blinks are happening due to that. Okay, during the wake stage. So desynchronized activity, eye blinks. Okay. Now what happened? Person closes the eyes during the sleep. Before going to sleep, or preparing for the sleep, wake stage, eyes closed. Initial slide was wake stage, eyes open. Now wake stage, eyes closed. What happened? So your EEG carries 50% of the epoch, like as alpha rhythm. Alpha rhythm means alpha activity is there, and it covers more than the 50% of the total epoch. 50% of total epoch means 30-second epoch is there, 15 seconds will be there. It may be like, it's not continuously. It may be like 5 seconds, then no alpha, 5 seconds, alpha is there. If comprise total 15 seconds, then it is called as the epoch is covering more than 50% of the, or 50% of the alpha rhythm. Okay. So next, how EOG look like during that time? So even during the eyes closed, person is awake. Okay. So slow eye movements just may be present, or mainly rapid eye movement also present there. Okay. But these are the not required criteria for the scoring a stage. Okay. And chin EMG. Okay. So chin EMG amplitude is variable, but is often higher than the during sleep. Okay, so EMG is higher, and whatever the EMG in sleep will, like, it is always higher than the EMG of this when person is sleeping. Okay, so this is how looks like. Eyes closed. Initial was desynchronized activity. There was no alpha activity was, but low amplitude. Okay. Here, when you close your eyes like this, and if you record my EEG, this will look like this. Okay. It's mostly prominent in the occipital region. Okay. So if you go up like towards the frontal electrodes, it is the power is less, the amplitude is less. Okay. So this is how your EOG looks like, and EMG is like higher because person is still awake. Okay. So if you see in convention, this was in software Polymath, Australia available software. Okay, this figure, and this is in Nihan Cotton. This is how wake stage eyes closed looks like. You can see there is so much alpha there. Okay, and this is your EOG, and this is your EMG. Okay. Now, transition state. Okay, so during this stage, eyes closed, person goes into drowsiness, and that drowsiness here you can see. Okay, so this is kind of wake state, and when this alpha activity, is replaced by low amplitude mixed. This is mixed frequency. You can see sometimes slow activity is there, higher activity is there. So this is a mixed activity, low amplitude, mixed frequency. Okay. Then again here there is like but there is alpha there. But now what is happening? Your alpha activity your alpha activity is replaced by is being replaced by the low amplitude mixed frequency, and you can see here slow eye movements now. So during drowsiness, you must most of the time you will have this slow eye movements. Okay, and slow eye movement I already applied that when first deflection happens, it should be more than the 500 milliseconds. Okay, so EMG again, this is kind of wake stage, should be kind of higher, and this stage, since it is covering more than the 50% of the total epoch, if you see here, and this part. So it is, I think, covering most of 50% of the part of the cell. So this stage is actually wake stage, but is transition to N1. So how this wake stage is getting transition into N1? So wake N1, okay. But due to the rules, we cannot mark it as N1. Okay, we have to mark it wake, because initially I told most of the epoch is covered by the wake stage. Okay, so it should be scored as stage brief episodes. Okay, this I told you already. When subject is disconnected from the recording equipment. Okay. So how to score N1? So eyes closed, eyes open, desynchronized activity, eyes closed, alpha activity is there, more than 50%. Now we'll move towards the sleep part. So what is happening in the sleep? In sleep, N1, N2, N3, and R state. So alpha rhythm is, so in wake stage there is alpha rhythm, and that has to be replaced by the low amplitude mixed frequency. So this low amplitude mixed frequency ranges 4 to 7 hertz. Okay, and if it is replaced by, if low amplitude mixed frequency is more than the 50%, okay, then your wake stage ends. Okay. So there is one more thing, vertex waves. So vertex waves are small waves like like this wave, this kind of waves are there, small. Okay, this I will show in the figure, and they may be present during the N1 stage. Okay, and they are not required for stage scoring and stage 1, but helpful. Means if you are not seeing that clue of that alpha is there or not, because some people does not produce this, they don't produce this alpha rhythm also. 10% of the population don't produce alpha rhythm. In that case, vertex waves are helpful. How it is helpful, we'll see in the figure. Okay. So slow eye movements are may be present in the N1, and these are not required for scoring N1, but they are helpful. If you find nothing, go for EOG. If low eye movement is there, low amplitude frequency is there, most probably it's N1. Okay. So chin EMG variable amplitude often lower than wake. Okay. So the now EMG reduced, like N1 is wake. EMG is greatest in wake, lower in N1, then more lower N2, more lower N3, then R stays atonia. Okay, that will discuss. Okay, so this is how N1 look like. This is okay. Okay, so this is low amplitude mixed frequency. Somewhere this alpha activity is there, but it is not covering more than 50%. Since low amplitude frequency is more than the 50%, so EEG we are. So EOG, if we see, this is EOG. So this is low eye movements are there. Okay, and this is EMG. So when person goes from wake stage to N1 in the early hour of the sleep, so there is not that much change in EMG, but later on there is a lot of changes in, there's like pronounced changes in the EMG. Okay, so EMG is higher, but so this you can see also. Okay, stage N1 output. This is your vertex wave is there. Okay, okay, this is called vertex wave. Okay. So vertex waves are mainly present in the central region. If you see prominence, it is more prominent here also. Okay, central region. Okay, so slow eye movements are also there. So these are the vertex waves, and this is how it looks like in conventional polysomnography epoch. Okay, this is your vertex wave. Okay, so how this is central, dominant in central region. Okay, so low eye movements are also there. Low EMG. And some people who do not like produce this alpha activity. Okay, so what else actually? EG activity of range 72 with slow background frequency by 1 hertz. Frequency 1 hertz from those of stage. Okay, so there is slowing of background frequency, and there is low amplitude mixed frequency, but we have to see there, we have to see the vertex waves. Okay, if vertex wave person is not generating alpha rhythm during the eyes closed, so when person shifts from wake to sleep, so you have to see for vertex wave only. LAMF means low amplitude mixed frequency, and with slowing of background frequency more than 1 hertz from the stage wake stage, and slow eye movements. If these things are there and person is not generating alpha rhythm, so that stage you have to mark then N1. Okay. So now we'll discuss about the arousal, then we will move towards the N2 stage. So score arousal. So arousal is like wakefulness, but small wakefulness. It is like okay. Score arousal during sleep stage N1, N2, N3. So in between sometime some wake happen. So what is the criteria for that? So arousal are like 3 seconds to 15 seconds. Okay. If it is more than 15 seconds, it is wake, because this alpha rhythm will be dominated by the, this one. Okay. This is dominated by the alpha rhythm, and when alpha rhythm covers more than 50% of the 15 seconds, then it's called wake state. But there is alpha, okay, EMG activity is also there, okay, but it lasts for like less than 15 seconds, okay. So in that case, it is called arousal. Arousal is defined as when there is a shift of the frequency towards the higher, okay. So low amplitude mixed frequency are these kind of K complexes are going on, and suddenly there is abrupt shift in frequency towards the higher activity. It may be alpha, it may be beta, it may be gamma. Okay, so not including spindles, that we will discuss about the spindle, and at least 3 seconds of this activity should be present. Okay, and preceding 10 seconds of stable sleep. So you can see this is a very 10 seconds stable sleep. This is for 30 seconds, and these are K complex. But this is this part. Okay, this part is called arousal. It's a transient wake or minimal wake. Okay, how it is useful in the scoring part and other, we'll see that. Okay, I think some chat question. Okay, K complex I will explain, and this Dr. Rafiq has asked some question like with your example of, I think I missed at that time. Okay, with your example of assigning stage with major portion rule, you use the 12 second for wake, 11 second for wake, and N1 as 7 second for N2. Why is it considered wake? So as I already told her, that 30-second window is there. Okay, this is a majority rule. This rule I am not deciding. This is ASM is deciding with their meetings with their group sleep specialists. So they came to know, okay, out of 3 stages are there in 30 seconds, which is covering most of the part. So in that case, wake was covering most of the part. That's why that 30-second window is designated as a wake stage. Okay. So you can ask question right now. If I could not explain very well, please let me know. I will try my best to explain it again and again, no issues. So please keep asking question. But these rules, if we go to next, after 3-4 slides, will be changed. Like these are general rules. When we come to the specific rules, some other things you will see now. Okay. So K complex I'm explaining next. This arousal I was explaining. If anybody wants to learn more about like arousal, okay, they are associated with the leg movement, they are associated with the respiratory efforts, okay, that's called ERA. So that we will discuss. But any doubt anywhere, please ask us question at that time only, no issues. Okay. Okay, so this is arousal. Okay, transient wake less than 3 seconds, less than 15 seconds. Okay, 3 to 15 seconds, and proceeding 10 seconds of stable sleep. Okay, so this is the. So in scoring part, you need not to tell that, okay, this is arousal. Okay, you have to specifically mark it as arousal. How many arousal happen in whole sleep night or per hour sleep, that you can mark later. But in sleep stage scoring, it affects the sleep stage scoring arousals. Okay, maybe because of arousal, the stage scoring may become N2 to N1. Okay, that may be there. Okay, that can happen. Okay. Why is it important to assign an epoch? Oh, so otherwise, first of all, there is a standard according to ASM. Suppose I am doing research here or doing patient here. So I need and duration of the. It is like I will explain. This is like 1 to 8 hours sleep is there. So I need to give, I cannot say this whole sleep is what. I cannot say that. No? I need to cut it to small parts. Okay. Okay. Like epoch wise. And I have to tell this, oh, this is N1. This is again N1. This is N1. Okay. So the data we have first 30 seconds, next 30 seconds, it must have some pattern. It may have some pattern, and that pattern we have to assign. Otherwise, we cannot score. Okay. So for that purpose, it is very important to assign an epoch. You can also assign as 20 seconds, but that is according to RT. Still, some researchers are doing for their scoring part, but in according to ASM is 30 seconds. But it is very mandatory. Otherwise, how would you do that? Okay, this is N1 is there or not if you cannot assign an epoch. Okay, if you go for 30 seconds, more than 30 seconds, like 1 minute epoch, so your recording will be very congested. You won't be able to find that whether it's K complex is there, spindle is there. Okay, so keep it like 30 seconds only. I think so. Importance is that if you cannot score without assigning a data. Okay, this is N1 or N2. We cannot do that. This we will discuss this whole recording, how we are, why we are doing epoching. That the video recording will be there next session. So that we will do. Next is okay, probably too wide. Okay. Okay, thank you. K complex. Oh, I will explain. Okay. Okay. So during the REM stage, if there is increase in the in this high activity, that is arousal. But if there is no increase in EMG, that is not called arousal. But in case of non-REM sleep, if there is no increase in EMG during that part, this is the non-REM part, EMG is increased. That is okay. But in case there is no increase in EMG non-REM also, it's okay. Like you can mark it as arousal. But in case of REM sleep, if there is increase in shift like towards beta and gamma, and there is no EMG activity, that time it is not called arousal. Arousal in case of REM sleep, you need at least 1 second of increase in REM activity. Okay, next. Okay, now sleep spindles. So what are sleep spindles? They are actually happen mainly hypothalamo-cortical oscillations. Okay, so I think Dr. Bindu and Dr. Vindra have explained it. What is the mechanism behind it? So, so how your spindle looks like? So these are the spindle looks like this. You can see here. This is spindle, 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 spindle. Okay, spindle actually their shape is like if ideal shape is like this. Okay. Oh, this is frequency. This rough diagram. Okay. So this is spindle. So what is the? So it's waxing and waning. Okay. You can see. Oh, waxing. Okay. Waxing and waning. So what is the duration? What is spindles like? Okay, we'll see. So sleep spindles, their frequency, this cycles. Okay. It is calculated in terms of frequency. It is like from 11 to 16 cycles per second. Okay. So the frequency of the spindles, it looks like this, and the frequency of the EEG activity here is should like 11 to 16 hertz, 16 hertz. Yeah. Mainly present in the vertex region in central region. Okay, if you see prominent here, it is in the frontal region. So it may be sometimes temporal or frontal prominent. Okay. Okay. So mainly, but during in the central region and duration. So this duration, okay, should be between like 0.5 to 1.5 seconds. Okay, so this duration like this this this. Okay, if it is less than that, that is not spindle. If it is more than that, is also not spindle. Some researchers use 1.7 seconds, 2 seconds sometimes for their research purposes. With the application of drugs or some disorder, they use more duration than this. But ideally, if you have to see like 0.5 to 1.5 seconds, okay, they are thermocortical oscillations and they are indicative of sleep stage 2. Okay, and drug spindles like benzodiazepine might be slightly faster. What do you mean by slightly faster? Like faster spindles. So spindle faster is like if I divide this 11 to 14 or 12 to 14, 14 to 16. Okay. So this frequency may be there, or this may be there. If this frequency, this is fast spindle and this is slow spindle. If we divide this frequency further, okay. So that is spindles. Thermocortical region, this is the shape and how it looks like, and mainly thalamus and cortex is involved in this, okay. And it is indicative of sleep stage 2. I think one question is there. Yes. If the disturbance lasts for 15 seconds, if disturbance is there, that may be major body movement, that will explain also. So if disturbance is there with increase in EEG activity, then that stage for more than 15 seconds, that will be next stage. Okay. Now K complex. Okay. So K complex is kind of okay. So K complex. Okay. So this is K complex. Okay. So mainly prominent in the frontal region. And what is K complex? And it is also indicative of stage 2 and 2. Okay. Sharp, slow wave is also known as slow wave. First, the negative deflection. You see, here is 50, minus 50. Okay. So this is negative, towards negative. First deflection is negative, then positive. Okay. Stand out from the low EMG background. Duration must be at least more than 0.5 seconds or equal to 0.5 seconds. Okay. You can see. Okay. And it is maximum. You can see that K complex are majorly present, like most prominent in the frontal region, then central region, then occipital region. See here something. This is EOG, PG1 EOG actually. Okay. Let me know time. What is it? I think Dr. Sheshagiri has come. Let us to check with Dr. Arun. We'll see that. If he is online, then I will take after him, after this part. I may take more time, so let him finish first. Okay, so you can see here. Okay, this is EOG, and still some activity is there. Okay, so how it is happening? Okay, so this is called the EEG artifact in EOG. Since this potential is very high, this EEG activity is high, the potential is very high. What are we measuring all about EMG, EOG, and these are all electrical potential actually. Okay, dipole potentials of brain and potential of electrode, this cornea and retina, and okay, EMG activity, this of maximum this muscle activity. So this activity which is present in the cortex, this is so much high, it travels due to body is conductive in nature. Due to this, the electrode which is present near the eye is also picking that. So this is so much high activity, even this eye is picking up it. So this is K complex is appearing in EOG because volume conduction, that body is conductive. Okay. So because of this is called EOG artifact. This is not eye movement. Okay. This is not eye movement. Indicative of stage 2, K complex associated with arousal require arousal to start no more than 1 second after K complex termination. Okay, so there is term called K complex associated or spindle associated with arousal. If K complex is there like this and arousal comes like within 1 second, so that is called K complex associated with arousal. If K complex is associated with arousal, that stage will not be N2. Since arousal is there, then that stage will shift from the N2 to N1. Okay. So that is called K complex associated with arousal. K complex is there, arousal is there, that activity, high activity is there, then it is K complex. So that arousal should come within 1 second. Okay. If it is more than 1 second, then that is not called the K complex associated with arousal. Okay. I think we have. Okay. Yeah, first question I will this one. Can vertex base be characterized in this epoch? In wake stage, if drowsiness is there, during wakefulness also, kind of we can see vertex waves, okay, and in the wake stage also, but vertex base mainly present during when drowsiness is there, okay, like N1 stage is there. Suppose person is in between the wake and drowsy N1. So at that time, you can also see vertex waves in that part. Okay. So I think my talk was about 12:15. I will start from this part again. Now Dr. Sheshagiri will give his talk. After that, in next session, I will start from here where I am leaving. Okay. So last question is there. I will explain this. K complex and vertex waves are quite similar. Yes, they are quite similar. If vertex waves is more than 0.5 seconds and with greater amplitude, that is called K complex. So you can say that vertex wave is kind of precursor of K complex. Sometimes, not always. Based on the mechanism, there are different things, but right now they are kind of similar. But you can have small K complex vertex. This we will see that. Okay. Now Dr. Sheshagiri will take care. After this, I will start again from next session. I will start from here.